So I saw this blog post posted somewhere. I actually don't remember where. It's called "The Skills That Matter Now," and I thought I would just do a quick read of it. I've not actually read anything further than the first paragraph thus far. I've had it on my mind to like talk about AI related things in terms of sort of like how it impacts me, how I've used it over the past like, handful of months or so. But I thought this would be like a really good and probably easier vehicle for me to share some like early thoughts. So again, I don't remember where I saw this posted, but I figured I'd go through it. I read I sort of like skimmed it just to see sort of like what the high level points were, but I made it a practice not to like actually read it until now. So the first paragraph, AI has made engineers more productive. There's no doubt about that. This is actually the reason I wanted to read through this article, because this is the one part of it that I actually already did read. I don't think you can say there's no doubt about that. Um, and that's on top of the sort of one of the observations I've made about the AI discussion is that the definition of productivity is definitely not there's definitely not consensus around there. Like lines of code being the thing that's talked about now, and as it always has been, like lines of code being sort of like a flex. So yeah, the conversation around productivity with respect to software generally is still pretty bad. The definition of productivity definitely needs some work. I did see an interesting paper the other day, and I'll have to do a video on this too, but where we're starting to see some actual research into the efficacy of these models and as they apply in terms of like actually accomplishing the goal of certain specific tasks within software. And this is another reason why I sort of wanted to camp on this first part, saying that there's no doubt about that. There definitely is, but we're starting to get some clarity there. But it's, of course, I mean, this is all going to be, you know, your mileage may vary effectively. What's changed is where the time goes. The hands-on coding that used to dominate our day is shrinking, and everything around it, such as planning, design, and review, is expanding to fill the gap. The role is completely shifting. That's been true for me for the most part. I mean, the I definitely wouldn't say the hands-on coding dominated my day. I mean, it did and it didn't. I'm speaking in generalities, right? Like, there would be certainly some days where it would be truly dominant, and then some days where I wouldn't do it at all. And of course, this changes as you become more senior, right? You're supposed to do less sort of hands-on coding, not none, but you're supposed to sort of like focus a lot more on relationships, design and review, architecture, figuring out what the highest impact things are, and so that way you target like what you spend your limited time and energy on more effectively. So like all that's true. I've been thinking about what specifically separates the engineers who are thriving from the ones still finding their footing in this new era of software development. It's not the tools they use, it's the skills they develop. Here are 5 that I believe matter most right now. Okay. Staying curious. I like this one. This is something I've tried. I mean, I'm actually trying to impart this on my children, and it's been the biggest thing that I've looked for when we hire new folks onto my teams. The teams that I've worked on that I've participated in interviewing for. Curiosity is a big deal. It's hard to teach also. In the past, an engineer who wasn't keeping up with the latest trends could still be productive for years on what they knew. The work didn't change that fast. That's no longer true. Yeah, it can be true, but yes, the specific domain in software that you're working on changes a lot of this dramatically. At the very least, the specifics change very dramatically. A good example is like, so who wasn't keeping with the latest trends could still be productive for years on what they knew. I mean, that's not been true in like front end for a while. As far as I can tell, I'm not a front end dev, but like from the outside looking in, it's always seemed like that was true. And then I also don't really think that that's like, again, this like absolute statement where this is true for, say, someone that works much more. I don't even want to say back end, because like my role I might call it back end if I was talking to like, say, a front end developer, but I call it like systems programming. So that domain changes far less rapidly. Doesn't mean it doesn't change, but I'm just saying like this is where the conversation is not evenly distributed, and it's something you need to be aware of as you apply articles like this to your own day-to-day. So the tools are changing monthly. The patterns for how to use them are changing just as quickly. 6 months ago, I hadn't even considered multi-agent review workflows. Now those are default parts of how I work. This is kind of also something that I've noticed where, this is the thing that bugs me probably the most about how like, stay off LinkedIn, by the way. Can I just do a little quick aside? Don't just stay off LinkedIn. It's the absolute worst. It's always been really bad, but lately, I mean, just with all this AI stuff, it's all I see. Literally all I see is such and such killed some other thing, or if you're doing this, you're doing it wrong, or so, like all this just it's as if the world forgot that we are all making this up. So the idea that someone would read that and be like, "Oh, I'm really doing it wrong," like, no, there is no wrong. We haven't even defined what it is. So yeah, like we're only now starting to sort of even begin to try to estimate the effectiveness of a lot of these harnesses. Again, I'm talking about from a practitioner who wears a pager, who it cares about quality. If you just want to yeet lines of code over the fence, you do you. But I'm going to be a little bit more measured about it, and I'm very pro AI in many cases. I'm not a zealot, but I'm very pro AI in certain cases. I'm also practical. The good news is that curiosity compounds. Each new thing you learn makes the next thing easier to adopt because you've built intuition for how these tools behave and where they break down. On the other hand, standing still is more expensive than it used to be. I wouldn't recommend waiting for the dust to settle. It's not settling. I've seen many takes about this kind of thing being like, if you don't jump in now, then you're going to be left behind. I don't believe that. I actually don't know. The point is nobody knows. So in terms of somebody sort of saying like you're going to be left behind, that's definitely not for sure true. It's not for sure untrue either, but it's not for sure true. But a lot of what I have discovered about how this stuff works, I did by just playing with it. And I do think that if you don't at least try to use these tools, it will put you behind, not in the sense of like, don't worry about the tool chain of the harnesses. Those things change all the time. But the just sort of like the intuition that you build over months of actually prompting and seeing the output and figuring out where it goes wrong, figuring out where it goes right. Like that kind of like mental model, it takes time to develop. It's still developing for everybody, and I include myself in that. So I would recommend getting involved with using a coding agent of some kind if you're in software. And so you should get involved with it somehow. And I think that somehow is up to you to define. But in terms of like, you got to find the rough edges. There are rough edges, and it's not possible for somebody to like list them in a blog. You're going to have to figure it out for yourself. So I would recommend getting into using Claude, OpenCode, Pi, Cursor, like whatever it is, it doesn't matter. The one that works for you is perfect. But I would recommend at least getting into it if you haven't yet, because again, there's some rough edges and there's some great things. Like I was surprised. I'm surprised all the time by what these agents are able to do. Okay, next, bias towards action. Curiosity alone isn't enough if it stays theoretical. The engineers pulling ahead are the ones who actually try things, and AI has made trying things very easy. Spinning up a prototype that would have taken a couple days now takes a couple of hours. Writing a proof of concept for an API design, making a web app, exploring whether an approach is even viable, all of that got faster. Totally true. I've actually built all kinds of prototypes. I have this like personal project that I've been working on for the better part of like 3 months, and it took like probably four different forms. I literally like prototyped a feature, but I built it like as its own sort of fully fledged software system that was like kind of self-contained, and then I kind of threw that out and incorporated the lessons learned from that into the next thing. So like that's definitely a new thing. Now there's two caveats here. There's two sort of risks here, because it's true. Like you can prototype anything you want, and I'm actually really excited about that generally, because if you are like me and like I have a wide variety of interests and I have no lack of like distractibility to say like, oh yeah, I have like these 20 ideas that I built that I had over the last month. Let's just go build them all. Like obviously that's in me to be able to do. But you have to sort of temper that a little bit. But the two caveats that I would add here, the two pitfalls, is these tools will not tell you if what you're building is worth doing. And in fact, they will almost always tell you, hey, that's a great idea. Like it's not a good idea to rely on these on Claude, for example, to tell you whether or not an idea is like good, or if what you want to build is the right thing to build. And I would be very cautious even relying on it to tell you if the way you want to build the thing is correct. I've had experiences of my own where it literally worked itself into a corner, because what it sort of suggested for me as a prototype, and I gave it this sort of really, really high level idea, literally was not possible. So there's definitely some pitfalls there. Don't offload your critical thinking skills about what is worth working on just because you can generate the code for an idea. Now, the other side of that is sometimes you have to generate the code for an idea to be able to build a mental model around whether or not it's worth building. That I totally agree with, as long as it's self-contained and you're not doing it against like some production code base. He continues, this should change how engineers approach uncertainty. The old instinct was to think carefully before writing any code because the cost of going down the wrong path was high. That instinct is still correct at the design level. Okay, yes, I agree with that. But at the implementation level, the math has shifted. Building a quick prototype to validate an idea is now cheaper than spending the same time debating it in a meeting. Largely true. Largely true. I think it really depends on the specificity of your design. The success, I've seen a lot more success in my own work, both personal and at the day job, with a much more constrained plan. I think in terms of like the success that I've had with building in this like a level of specificity at the design level, that's also made this task specifically, not even the implementation, but literally this task, the design task, has also been improved, I think, by using coding agents because it can give you the ability to very quickly iterate on design and get a level of detail in there that would have been sort of prohibitive in the past. So I love detailed specs. I prefer them, and I push anybody that I work with to incorporate more detail into their designs and their specs. And I think the reason for that is because and this is before AI, the reason I've always done that is because, again, I think it provides far less friction down the road when it comes time to actually writing the code, doing the review, and then operationalizing the thing. Like, all of that becomes a lot more simple if you build more specificity in at the design level. So like if you have a spec that says like, oh, we'll make this database schema and it'll have these fields, and you just kind of list them. Like, I think that already didn't work for humans, and it's going to work a lot less for LLMs, because I think humans, being actual intelligence, are able to make leaps that LLMs are not able to make. And so if you keep things that ambiguous at the design level, you're going to get what you pay for. So I don't disagree with the general idea of this paragraph. I just want to make that aside because I think this is one of those things where we had bad habits before LLMs, and if we carry those bad habits into LLM territory, then it's gonna get even worse. Be honest with yourself about what's working, though. An METR, I don't even know how to pronounce that, METR study found that developers believed AI made them 20% faster while objectively being 19% slower. Experimentation is cheap, but self-deception isn't. Try things, measure whether they actually helped, and adjust. The goal is experimentation with feedback loops, not just vibe coding. Wholeheartedly agree. I've given this advice to team members in the past, very recent past, in fact. I had a team member come up to me and ask sort of like, so I can't remember the specific wording, but it was something along the lines of, hey, I saw that such and such pattern is no longer like, accepted. It's not in vogue anymore. And the response I gave to them was basically, who cares? Like all of this stuff is changing so rapidly and it's so new. No one has any idea really, certainly not in a general sense and over long term, because there is no long term, how effective a lot of this stuff is. So trust your gut, sort of keep your brain turned on. Don't, I think it's a double-edged sword, deceiving yourself into thinking like the thing that you're building is the right thing. Obviously, don't trust your gut in like every respect. But in terms of sort of what how you judge your output, judge it the same way you already did. Don't change that necessarily just because you have LLMs. You need to keep your head on your shoulders. You need to think about things like, is what I'm working on the best thing to be working on? So yeah, I would say, like, be very wary of this tendency to equate productivity with just writing code. Okay, systems design mindset. Coding is no longer the hard part. I haven't considered coding the hard part for a while, but again, maybe I'm alone in that. This goes into a video I've wanted to make for a while about bottlenecks. You've probably heard on social media this notion that like coding was the bottleneck, and now the bottleneck is gone. I don't know. I don't know that I have all my thoughts collected on that, so I'm not going to say too much because I'm still trying to figure it out. But I have this sort of hesitance to agree with anything like that, like coding being the hardest part and now it's gone, or the bottleneck and now that bottleneck is gone. It doesn't pass the smell test for me, but I'm not sure exactly what I find wrong with that. For most tasks, a good coding assistant can produce a working implementation faster than you can type it. Where engineers still provide the most value is in the architectural decisions. For example, whether the code is maintainable, scalable, and correct at the system level. Yeah, I mean, yeah, I agree with that. I think this is, again, there's a big temptation right now to offload a lot of that thinking to an agent just because it will agree with whatever you say, and I'm trying to fight that all the time. So yeah, definitely true. Systems design is more important than ever. Prototyping and implementation is cheap and reversible, but committing to the wrong abstraction, the wrong service boundary, or the wrong data model cascades through everything that gets built on top of it. That's where getting it right up front matters more than ever, and AI will overlook these decisions or it will make assumptions if you don't guide it carefully. Wholeheartedly agree. Uh, Again, these models are all trained to produce. They're obviously, like, at its very core, they're next token predictors, right? Um, that is at the foundation, and also they're trained. The way they're trained specifically is to sort of like it's to sort of agree with you and think and help make sure that you feel like you're being productive and making the right decisions, even if they're not the right decisions. So yes, I agree with all of that. And guiding it carefully, I've had overwhelming failure when I didn't provide a lot of constraints onto what I wanted. So emphasize the planning stage. Use whatever plugin works for you to make sure that the plan is built out well and is specific. Use like try to find plugins or even just like custom agents that you can use that do sort of like Socratic style interviews. And again, don't rely on the agent to always ask the right questions. Definitely don't shut off your brain in those and assume that once it's done with its questions, then those are all the useful questions. Like, you need to still do it to yourself. But I've found agents or plugins that use Socratic style interviews to be a good, at least, starting point, like as a vehicle for me to start thinking in that way. You have to be your own devil's advocate. So yes, I agree with this paragraph. If you don't guide it carefully, it can go off the rails. And so constraints. I'd encourage every engineer to get comfortable spending what feels like too much time on the design step. Yes, that's been true for a long time. In my opinion, design and again, specificity on design specifically is what's been missing, I think, in the industry, at least from what I've observed. It just the 9 out of 10 times specs are sort of like a checkbox thing that most engineers do, and they're like, well, let me just get right to the code. And I've felt like that was a sort of a deficiency in the industry for a little bit. Sketch the components, define the interfaces, talk through the failure modes, review it with a peer, then hand the spec to your coding assistant. The code will be better, the rework will be less, and the system will hold together under pressure. Reviewing with intent. Every time you accept a suggestion, approve a plan, or commit AI-generated code, you're doing a code review. It's no longer just a PR gate. It's part of your inner loop. This constant oversight matters more than ever because the volume of code is increasing exponentially. A slop code bench study, definitely going to have to look at that later, found that agent-generated code is 2.2 times more verbose than human-written code, and quality degrades with each iteration. Let your agents loose untethered, and you will build up what Adi Osmani from Google calls comprehension debt, the gap between how much code exists and how much any human genuinely understands. Yes, absolutely. I regularly forget and deal with sort of like the cognitive burden of a series of code bases that were, for the most until recently, entirely untouched by AI. So yes, I can totally see this getting out of hand. This is another thing I want to talk about maybe in the future, but I'm going to actually bookmark these links. I'd love to read more about those. I think I've read this one. I've heard the term comprehension debt before. This is a great term that I wish I'd coined, but it's a feeling that I've had a long time before AI came onto the scene. So how can we review all this code without drowning in it? Review it at the right level. Nits are fine, but they're not where the value is. Maybe they never were. But the important questions are structural. Does this follow the patterns we've established? Is this abstraction right? Are there hidden coupling points? Does this fit into the system, or does it just solve the immediate problem in a vacuum? When I wrote about structuring a team around AI-assisted development, we found that shifting review time from implementation details to design and architecture was one of the highest leverage changes we made. I do also worry about the volume of reviews. You're reviewing code now, I think, twice. You see it as it scrolls by, and hopefully you look at it so kind of 3 times. So you're reviewing the code as it scrolls by in your agent, and I'm not sure if there's maybe I'm using the wrong tools, but I've never loved the sort of the UX around coding agents. When they make changes, it sort of just scrolls by, and so you have 2 choices. You either just say, I'm going to approve one at a time. And if you approve one at a time, then you're in more of you're more in control. But then, like, it just makes a patch to a file, and if that's not viewed within the context of all the other changes that it's about to make, it may or may not make sense. So for me, it's the other choice, which is to allow all edits and just rely on git diff, which, it could be a huge change, at which point it's kind of too late to course correct. So I don't know if somebody has an idea about like a better UX that's out there, I'd love to hear it. But I've always felt that is kind of it's just not as good as I think it could be. But yeah, I mean, use Git. That's the easy answer for now. But anyway, that's sort of the second stage of review, is actually looking at your git diff, and then the third stage is the actual review in like the merge request or the pull request or whatever it is. So that's its own thing. And then you have the sort of the sheer volume. Yeah, reviewing is definitely a problem, I think, right now, or it's becoming a problem. Okay, pattern matching. I think this is the last one, right? Yeah. So in a previous post, I wrote about 4 patterns for AI-assisted development: one-shot, plan mode, spec-driven, and multi-agent workflows. Each is appropriate for a different level of task complexity. Yeah, sure. I've used all of these. I think that you should consider them tools in the tool belt. Over time, this could or should become second nature. A simple function rename gets a one-shot prompt. A new API endpoint gets plan mode. A cross-cutting feature gets a spec that's reviewed before implementation starts. A large feature in a complex code base gets a multi-agent workflow with quality gates. The most common failure mode is defaulting to one-shot for everything. It works great for small tasks, but for anything with real design decisions, skipping the planning step means the AI is making architectural choices on your behalf without you even noticing. The second most common failure mode is over-engineering, running a full multi-agent pipeline for a task that needed a 2-line edit. I mean, this is pretty obvious. I think this is the thing that's less likely to trip people up. If you are if you've ever used a multi-agent pipeline, the idea that you'd sort of lay that onto a 2-line edit. I don't know. I'm sure people will do it, but I just don't think it's common. The thing that draws my attention is actually the first one, is skipping the planning step, and sort of, again, the pitfall here is that the AI is making architectural choices on your behalf without you even noticing. That is incredibly non-obvious. Like, what is the threshold? What even is that threshold? How do you even begin to know when a given task or prompt is complex enough that the AI is going to have more leeway to make weird choices that may not be in alignment with what you want? I can't really define that, other than to say, as I mentioned earlier, this is one of the reasons why, if you want to sort of learn how these tools work, you just have to get your hands dirty and build kind of anything, right? Build anything. Try to sort of stay on top of sort of like the value of what it is that you're building. But yeah, using this for prototyping is a great way to start to build this mental model. And it's hard. It's a hard mental model to build if all you're used to, again, is this the pre-existing model of everything's deterministic, and this is not deterministic. So there's no real sort of hard definition of what that level of ambiguity is. Maybe the models will get good enough to estimate that ambiguity for us. They're not there right now, but yeah, I mean, this is the thing that I think is profoundly still very human, is the intuition of when a given prompt is complex enough to warrant more guardrails. Like, how do you know when a given prompt is going to give a model the ability to make crazy architectural choices without you even noticing? That's not obvious. I think that takes a lot of time and practice, and it also takes a lot of experience with, again, building and operating a production service comes with it, because if you don't have the pain that comes from when things go wrong, I don't know that you can have that kind of real good instinct. I don't know that you can't either, but that's, again, I'm speaking from my experience. I built all of that intuition from learning the hard lessons and whatnot. So for me, that's where I come from with this, is I need to use these tools to find out where it can go wrong, and the definition of what wrong is based on all of the experiences that I've had in the past. So that's for me, I guess. The skill is pattern matching, knowing when a task deserves more investment up front and when it doesn't. That judgment comes from experience, and the only way to build it is practice. Okay, great. So I'm glad I didn't read ahead, or maybe I should have read ahead, and then I wouldn't have gone on that little rant. But yes, I agree with this. That judgment comes from experience. You just got to do it. You just got to build stuff. All right, bring it home. The common thread. All of these skills point in the same direction. The value an engineer provides is shifting from the mechanical to the architectural, from writing code to deciding what code should be written. None of this means the fundamentals stop mattering. You still need to understand data structures, concurrency, systems design, and debugging. In many ways, you need to understand them more deeply because you're now reviewing and steering code rather than writing it line by line. The tools will keep changing, the models will keep getting better, but the essence of the job is still engineering. Contrary to what you may be hearing, that's not going anywhere. There's just a lot less typing and a lot more thinking. Yeah, I mean, I think generally, I love the blog post. I agree with almost everything in terms of the message. I think there's definitely a lot of nuance to be captured there. There's such an overwhelming temptation with these models to turn off your brain, to assume that they're more intelligent than they are, and I think the message around this blog post in particular, which is a good one, is keep your brain turned on. Trust the judgment that you had before these tools to some extent, right? Don't just give in to every sort of whim that you have. But in terms of sort of the things that are uniquely human, which is, they say people talk about taste. I think that's a little bit reductive in terms of generally just like good intuition of what's worth working on and what good architecture is. Yes, I think all of that is very still uniquely human. I don't think that the current tools are anywhere close to being good enough to offload that. And to be honest, the day that happens, we probably have something pretty close to true AGI, at which point none of this matters. All right, thanks for watching. I will see you on the next one.